Hello guys, in this lesson I want us to cover a concept of a mixture. So this lesson is going to be useful to those learners doing grade 11 and grade 12 mostly because they're doing those complex calculations of quantitative aspects of chemical change and acids and bases. So now straight into the lesson. What is a mixture? A mixture is simply a combination of two or more substances mixed together, and we understand that a mixture can be homogeneous, it can be heterogeneous. Now, what is a heterogeneous mixture? So a heterogeneous mixture is simply one mixture whereby you can tell the substances apart, the substances that make up that mixture. So you can see ukuthi no man, this is ushukela inhlabathi layer, but it's one mixture. You understand? So that means the substances are not perfectly mixed because you can tell them apart. And then if you look at a homogeneous mixture, it's one mixture whereby you cannot tell the substances apart because they are perfectly mixed. For instance, when you are drinking coffee, you cannot point at the coffee, ukuthi nanti coffee, here's the sugar, here's the water, here's the cream water, because it's a perfectly mixed mixture. So we say it's homogeneous and cannot just be separated by physical means. Awukwazi ukuthatha ushukela ubeke eceleni, uthathe ikhofi ulibeke eceleni when you have actually combined these ingredients that make up a tea. Now, I'm not really there. I want us to talk about the acid-base mixture. What is an acid-base mixture? Self-explanatory. It's a mixture that is composed of an acid solution together with a base solution. So together we call them an acid-base mixture. Now, a reaction between an acid and a base is known as a neutralization reaction. And again, as the word suggests, neutralization reaction, it means that in a chemical reaction, the acid will try by all means to neutralize a base. Likewise, the base will neutralize an acid. Okay? Now, I want us to check the relationship between the substances before they are mixed together and when they have finally mixed. Now, I want us to look at this neutralization reaction, this chemical reaction between an acid and a base to give us this mixture being the final solution. Now, what happens? A lot of people will quickly assume that if an acid is reacted with a base, the final product will be acid plus base. It's not the case. The final product is not acid and a base. The final product is acid or base. So why am I saying that? Now, in grade 11 and grade 12, learners are encouraged to always try by all means to determine the excess and limiting reagent, because in a chemical reaction we understand that one of the reactants will be used up completely and the other reactant will be in excess. So between the two, one of them might be in excess after the reaction is complete. So the one in excess is the one that remains as the final solution. Okay, the only difference is that it has an increased volume because of the additive volumes that actually took place there, okay, when these two solutions came together. Now, it has an increased volume, but it's actually the substance which was in excess. So it's not base and acid, rather it's base or acid, depending on which one between the two of them was in excess. Now, the final solution is the excess reagent between A or B. If you say that we have A and B in the final solution, you mean to say that there was no reaction that took place. So this is not just a mixture whereby there's no chemical reaction taking place. Because there's a chemical reaction taking place, one of them is used up and the other remains as such. So the other one that remains becomes the final solution. So the final solution is one substance, being the excess reagent. So that means if you know the concentration in the final solution, you actually know the concentration of the excess reagent. If you know the number of moles here, you know the number of moles of the excess reagent. And once I speak about the amount in excess, the amount initial, the amount used, you know the mathematical relationship we're using in quantitative aspects of chemical change. Now, let us continue. Lucky for us, we can determine on whether in the final solution we have an acid or a base, because we know the properties of an acid, we know the properties of a base. What are they? We can differentiate between an acid and a base using the pH. So what do we know about the pH of an acid or a base? The pH of the base, what do we know about it? The pH of the base is always greater than 7. So if the pH of the final solution is bigger than 7, or if you are told, okay, that it's bigger than 7, then you must understand that the base in that chemical reaction was in excess, and that is your final solution. That's a substance present in the final solution. And if the pH of the final solution is smaller than 7, this is a property of an acid. It's a characteristic of an acid that the pH is smaller than 7. So a less than 7 pH gives you an excess reagent, being the acid in the final solution. I hope that makes sense. Now, as we did say that the volume that is in the final solution is increased. So how can you find this volume? It's simply the sum of the two volumes that were added together. So now the volume of the final solution at C is the sum of the volume of the base plus the volume of the acid, just like that. And we did mention that once we talk about an amount in excess, if we have an amount in excess, we can use this relationship as used in quantitative aspects. How to use this relationship? In the same way, if you have money, if you want to know how much exactly have you used, if you want to find the amount that you have used, imali that you have used, or imali that you have spent, what do you do? You're gonna say the initial amount, the initial money that you had, minus the amount that you now have. So what you had initially minus what you now have will give you how much was used. So now this amount that I've circled here is the one that can be used in stoichiometric calculations when you're doing the mole ratio calculations, when you're comparing the two substances, okay? So now we don't normally use the initial amount or the excess amount unless they were reacted as well. We always use the reacted amount or the used amount, okay? So that is why it is important that you always subtract the initial, you subtract from the initial, taking away the excess amount, because this is the value that we use in stoichiometric calculations using the mole ratio. We use the change, not the initial, not the excess. Now, so the reacted amount can be mass reacted, it can be the number of moles reacted. So it's the same formula as that. I've just replaced amount with mass and number of moles. I did say that everything here is excess, so we can use this relationship to find the concentration in excess, number of moles in excess, and of course this is our total volume, meaning that we can find this total volume using this relationship, the volume being the sum of this and that. Now, let us do this interpretation to check if it's making sense. I'll try by all means to just rush through through these interpretations. We're not going to do calculations per se. So you can see that I have similar diagrams, and I think you can interpret this problem. So I'm not going to read the statement, but I'm just going to give you the most important information that is present because of time constraints. We know the pH in the final solution. Remember, we said in the final solution we either have an acid or a base. So what do we have in this case? pH of less than 7, we have an acid. So our solutions that are being mixed is sodium hydroxide and hydrochloric acid. So hydrochloric acid is the acid. So that means we still have hydrochloric acid in our final solution because we can see the pH of less than 7. So whatever number of moles you can calculate from this pH will be the number of moles of hydrochloric acid in excess. And these amounts before mixing them, they are always initial amounts, meaning that you can say initial number of moles once you have calculated them minus the excess number of moles, which will give you the used number of moles. So once you have the used number of moles or the reacted number of moles of HCl, you can therefore find the number of moles of sodium hydroxide. You also have the volume, so you can answer the question that is looking for the concentration of sodium hydroxide. In a similar way, you can do this calculation here. So now what do we do? So in this calculation, we are given the pH of the mixture. It's an 11.4, meaning that the mixture had a base in excess. And through reading, you can find the initial amount, and through this pH, you can find the excess amount of the base. And then you can just work out your quantitative aspects of chemical change calculations to discover or to determine the initial concentration that is not known between the acid and the base. Now, I want to move to these formulas. Now, you understand that if you are looking for the pH, when you have the concentration of the hydronium ions in that acid, you can find the pH using this formula. But in the previous two pictures that we just saw, we were not given the concentration of the hydronium ions. Rather, we're given the pH of an acid at first, the pH of hydrochloric acid. So if you're dealing with an acid, this is your formula. So you're just going to substitute that pH. Do you remember it was a 2? So you're going to say 10 to the power negative 2, and that will be the concentration of the hydronium ions of hydrochloric acid. So this is not the concentration of hydrochloric acid. It's simply the concentration of hydrochloric acid hydronium ions. I hope that makes sense. And then if you are dealing with the base as in the previous picture, this will be the concentration of the hydroxide ions in the base. It's not really the concentration of the base. Now, how do we use these to find the concentration of the acid and the base respectively? You can do a dissociation reaction of that base, and then you move from the hydronium ions to determine the base concentration, or you can move from or the hydroxide to determine the base, and then the hydronium to determine the acid as such. Now, what is the relationship between the hydronium ions and the monoprotic acid? The monoprotic acid is HCl and nitric acid. So now, in this case, if you have found the concentration of the hydronium ions, it will be equivalent to the concentration of HCl. Okay, but if you are talking about a diprotic acid, you've got to divide this concentration by 2 in order to find the concentration of the diprotic, and you're going to divide this concentration by 3 in order to find the concentration of the triprotic acid. Or you can just use 1, 2, 3 as formulas if you want. Thank you.